Hi everyone, this is Mohammed and welcome to the introduction to Neo4j graph database in design and construction. Well, this will be our first video in this series, and as an introduction to the Neo4j, we would lay out the foundation and understanding its concepts around. In part two, we will be exploring some of the real world use cases such as clash detection, supply chain management, and in the third video, we will dive into the graph rag, um, AI agents, MCP, and some of the intelligent workflows. Okay. So over the last few years, we have seen a massive rise in AI and LLMs, and these systems they can write, summarize, reason, but there is a problem, right? So the AI system, they don't actually understand your project data, right? And some of these concepts we did covered in the past in my MCP tutorial, right? So, but the topic here is more around Neo4j. So how Neo4j really solves these challenges, right? So to solve this, industry they came up with the RAG, where AI retrieves information from the external data sources before generating the response. Right? But most RAG systems rely on documents, PDFs, and structured or unstructured text, right? That works for reading, but it fails when it comes to the relationship. Okay. And this is where in the AEC industry, the relationships are important, and this is where the knowledge graphs comes in. So a knowledge graph represents the data and in the form of nodes, relationships, and properties. And what we are looking today is an application called Neo4j. Neo4j is a graph database. It's an open source. It's not new. It's been around there for over years now. Okay, but it has got some attractions now because of the LLM. So you can directly push certain queries that can help you to visualize this information. So for now, what you need to understand, in case if you are not aware of the Neo4j, so Neo4j has three main components. One is the nodes. So think of this more like in a Revit terminology, like as category. So you have walls, for example, as a category, doors and spaces and the systems, right? And it has a relationship. So for example, how many elements are there on a specific level, right? And for example, door has been hosted on a wall, right? So that's a relationship, and the wall is on a specific level. And each of these objects, they have parameters like metadata attributes, right? And Neo4j helps you to write queries to interact with that data or whatever the data source that you connect it to in the form of Cipher language. So Cipher is a language that sits on top of the Neo4j that helps you to query the data. And as you know, that BIM is not just about geometry, it's a connected information, right? And we do use so many tools. So we got BIM models, we got spreadsheets, we got reports, calcs, so many other documents, right? And so many applications that you use. So everybody produces the information, right? And this is one of the applications that can help you to intelligently connect all of these different nodes together and make this relationship and helps you to visualize that data. Okay. Just before I go to this slide or the other slides, I just wanted to quickly run through. So the Neo4j, it has a website that you can go to the website, you can download the application. There is also a remote version to it. But again, we will not go through too much in details on this application. But what is really good to understand at this point is that I have downloaded a desktop-based application. So this is where I will run through with you, where what we will be looking at is the nodes, the relationships, the property keys, and some of the basic UI. Okay, and then explore some of the visuals. So as we were discussing in the previous slide, so we got nodes, relationships, and the labels and the properties, right? So the nodes has all of these different components like your walls, doors, windows, and system elements like HVAC, etc. And for the spaces, you got all of these rooms, floors, etc. Okay. In the next video, we would be looking at loading an IFC model that can really help you to understand those different schemas that can be connected with it. Okay. I have not planned exactly the date for the next video, but hopefully should be sooner. So now you got all of these different nodes, which are in the form of the categories. Okay, and then you got these different relationships. So for instance, you have a belongs to discipline. It's a relationship, has levels of category, etc. So you can further define all of these different components, and then all of these has these properties, like the labels and the parameters, right? In order to build this, what I have done is that I have used one of this example model that I had, okay, and I exported all of these information from this model into an Excel file, and I connected that Excel file to the Neo4j, okay. And the way that I did it is that, for instance, in this specific model, I have got quite a lot of these levels. So there were somewhere about 90 plus levels, okay, and to 94 levels in total. And then I have got quite a lot of grids and other walls components, and there are some furnitures, etc. It's just a dummy model, okay. But the whole purpose is that we will just use this model to understand the context through the Neo4j. Okay, so what I did was I exported all of these data to, so whatever the elements which are visible in this specific view, I have used this specific plugin that can help me to extract all of the element of which are visible in this view in an Excel file. So when I run this command, it is going through about like 2700 elements which are visible within that view, and it gives me an Excel file, right? So, and within this Excel file, I've got all of these different categories which are visible within that specific view. So for instance, if I go to the wall, I can see all of those different properties that are there for that specific wall. Okay. But again, this is just an example of what that data source. So it could be an Excel, it could be a JSON file, could be so many other file formats, right? But the whole idea is that we got the data and we took this data and then we connected that. So just to show you the statistics of these database, I have somewhere about how many? So all of these different categories, they count somewhere about 2700 plus instances. And all of this I went through and then ran through and then created some relationship that came somewhere about like 41,000 relationships. Okay. But if you do have some Word document, for instance, or a PDF or some another information, this is where the large language models comes in place, where you can use either MCP or other workflows to push this data to the Neo4j. Okay. So I'll quickly go back through the slide. So this is where we just discussed about these various nodes, relationships, and the properties. I'll give you another good example here. So for instance, in a sense of a digital twin, imagine you have a building, right? Each building has a set of spaces, right? Like your rooms, etc. And rooms has components, you may have some sensors, etc. So these these nodes connects to each other. So for instance, this room belongs to this specific building, and it is monitoring the sensors. It has some data point, and then you have, to that data point, you may have some time series analysis. So all of these different relationships you can very much visualize with the help of the Neo4j. Right. So for instance, tracking a specific asset, or even with the predictive maintenance. Right. So for instance, we will look into, when we go through the application, we'll look into some of the ways where you can understand some of these data very easily. Okay. So here nodes, you got all of these different assets, room systems, and then relationships. So it's located in, so for instance, if this specific equipment is located inside a room and it is supplied by a specific system, and it might have some issues, right? So if you are relying on some of these data which comes through the sensors, then this could be a good way of visualizing this data. Okay. And if we look into the traditional way of the relationship database, were designed for transactions, right? It's not relationship, right? And this is where the relationship, they were also not direct, right? They were indirect. So your queries becomes complex and slow, and the performance and the connectivity issues, etc. Okay, so this is where this database can help you to understand the context. Okay, I'll probably share the slides, but I'll quickly run through the other one because I was hoping to finish this in 15 minutes or lesser than that. If not, this video becomes boring. Okay. Again, this is a series, so probably if I don't cover anything here now, then we would eventually cover into the other series. So I initially thought of having 3 videos, but hopefully this should eventually grow. All right, so what we looked into is that we took the Revit data, we exported it into an Excel, we then connected to the desktop-based application. And if I, okay, then let's just quickly jump now to the desktop application. So here you can see that there is a cipher reference here. So some of these queries which are happening here, they are basically can be accessible from here. Because I'm using a desktop-based application, I'm also running a local instance on my machine. So that's where it's happening here. Okay, so I'm running this on a specific port on my machine, but there is also a desktop-based application, as we discussed before, and these are the different queries that can help you to interact with this specific model. So in this instance, what we are looking is that we are checking the number of faces, and we are trying to return the total length, which is like 25. Okay, but currently in our model we only have like one face. Okay, in this instance we are trying to query this based on the project. So what I did is, when after I extracted all of these Excel, I ran through my Python to query and to clean up a lot of data, and then created those relationship and then push it within this specific system. Right. Okay. So now, for instance, let's say if I go back here to the database overview, I would look for instance, we did discuss that there are some grids within this model. So I'll just click on this grid relationship. Now we can see that this specific project, or that's the name of the model, right? So which is the building, and it has 16 grids, and I can see all of the grids information here. So there are the different grid names. Okay. If I have a specific query, then I can use or write in the form of cipher. Okay. So this is just one example, just to show you that what we are querying here is that we're trying to get the element count based on the discipline. So when I run this, it gives me a tabular information saying that out of those 2700 that we have talked about earlier, then those are the elements that have been distributed in this form. So I've got some 99 structural components, fire protection, HVAC, and electrical. Okay. If I look for instance, level here now, then I can see all of the different levels here. And we discussed before that in the model we got 94 levels. So now instead of limiting this to 25, I can increase the number to 100. And then after I write this script, I can execute the query. Now this should give me all of those different levels. So there are total 95 levels that we have. And I can click on any of these ones to understand its relationship. So now, for instance, this tower has these many levels. Then again, I can increase the limit. And if I look for the has grid or the host, etc., then I can further explore and I can map this. I mean, just this for this example, I did not went through a lot, but this is just an introduction. You got all of these different labels and the properties here that you can further use to query with the help of Cypher. Okay, there is another instance to this, which is the Explorer. Okay, within this Explorer, what you can see furthermore is, for instance, if I zoom in a little bit here, so that's the project, right? The project has this specific discipline and all of these elements which are connected to it. So of specific category, has level, and all of these information that we can define it in a more relevant way within that query. Okay. And this is one way of representing it, but you can also change the layout type. So for instance, if you want this to be more hierarchical or circular layout, that you can further look for. And this got all of these different nodes and symbols that can help you to understand this data. Okay. And another thing that you can do is, for instance, if I just clear this scene, I can click on this search here and I can say building has levels, right? And I can execute that query. So now I can see the specific building has got all of these different levels. So probably this may not be the best view to look into, but if I go here to the hierarchical layout, then we can understand that that specific building has all of these different views. And similarly, if I just clear the scene back again, go here and I look for door, then it hosts on specific wall, right? Then I can further execute this query. Probably this one would take some time because I have got quite a lot number of doors and wall. Okay. Okay, hopefully it should be returning the the result. Okay, I need to be a bit patient with this while this is loading up. Okay. I mean, there's a lot of data. I mean, it will slow down the machine. So again, we can utilize all of these different properties, etc., that we have that can help us to understand, like, tracking of the material, tracking of the cost, all of those different relationship that you can define within this specific system. Okay. So again, Neo4j, it really helps to move beyond some statistic models and towards some living systems, which is in the form of this visualization, right? So I think this is it for this specific video. Thank you very much for watching, and I hope you find this education